Hi, this is Lo. I'm here today to give you a lesson about completing the square. Basically, I find that most people I run into when I talk to them about math, this is something that they normally run up on and have a little bit of difficulty understanding the concept behind and what you're doing. So essentially, when you are completing the square, you're converting a function into vertex form, um, or some people call it standard form. It really depends on who you're talking to. But let's look at the pros and cons of each form and why you would want to use which. So there's your normal quadratic equation, right? Or I should say quadratic function. This form is really designed to be plugged in to the quadratic equation to find solutions. As well, it's probably the most used form. This is the form people normally use when they're doing most of the math that they're doing, just because it's easier to keep track of the terms and everything like that. Now it depends on what you're trying to do. Like you can easily find the y-intercept in this form, and depending on what is a, b, and c, you can factor it and do a bunch of different things to it. Now to the vertex form over here, there are also pros and cons to it as well. You can tell exactly where the vertex is, and that's really useful because sometimes you don't need to know the exacts of a function. You just need to know just the generals, like where it's going to be, which quadrant it's in. It really comes into play later on in like calculus and a few other things as well. But just know that each form has its own benefits and their own shortcomings. But essentially, you can convert these forms back and forth as needed, depending on whether you need certain pieces of information on your functions. And I would even say that this form becomes irrelevant later on, though in calculus they still use it to solve very specific situations. So keep that in mind and don't forget how to use this. So I'm going to start now describing something that a lot of people don't understand when they first do this. Essentially, you're going to add by 0, right? So if I have the number 1, right? If I add 0 to it, you're going to tell me that was redundant. It's still going to be 1, right? Well, I can do a lot of different things. I can add 0 a bunch of different ways. Let's say I have 1 again, right? But this time I'm going to add 2 and subtract 2. You're going to tell me that's still 1. Essentially, we're doing the same exact concept, but in a function instead. So don't get weirded out by that. It's just something that people do in mathematics to make it easier to work with, and you'll see what we're doing in just a bit. So let's start now. So we have x squared minus 8x plus 5 equals 0. I always like to start with getting rid of the c term and throwing it on the side with the 0. It's just easier because it's less to worry about. Everything that doesn't have an x term, I try to just isolate it on the other side of the equation and not worry about it. So that's simple enough. You got x squared minus 8x equals negative 5. Okay, now what you got to do from here is essentially complete the square. And how you complete that square is you take b, the b term, divide it by 2, and you square it. That's going to give you what you need to put into here on this side of this equation to essentially complete the square. But you have to add it by 0. So you're going to add a positive version and a negative version so that they cancel out. Before they do that, you're going to group them together so you can collapse the function into essentially the vertex form. And then you're just going to do a little bit of cleanup after. So I think that a lot of people get hung up on this concept, so I'm going to bring up some visual aid for you, okay? Welcome to the visual aid. This is the classroom that we will have whenever we have a visual aid. And I'm going to build basically structures outside of this classroom to describe the concepts that we are doing. Now these set of structures here describes what we're doing when we are completing the square. So let's go over here. This is the first structure we need to look at. So essentially what we have here, right, is we have our x squared and our bx. Now you might ask me, how? Why? Okay, so imagine this length of this side is x, and this side is obviously the same. So this is also x. So this side is x, but this side right here, that is our b, right? So we have x times x, so this is x squared, and x times b, which is bx. Now, as you see here, we have essentially two um, separate terms, right? But essentially what we're going to do is make a square out of them. Now remember, in our equation, what we did is we took that 5 and threw it on the other side. So that number 5 is irrelevant in this situation. Just focus on the x squared and the bx. So now what I have done is I have essentially cut up the bx and arranged it so it's almost a square. Now, if that length up there was b, that means this length up here has to be b over 2. And this length has to be x, and that is x. So essentially this entire length right here is x plus b over 2. Now, what is the missing piece? Well, if this is b over 2, and if this is b over 2, then this little piece right here has to be b over 2 squared. That's essentially how we got that little function I showed you earlier, b over 2 squared. Essentially, that's the missing puzzle piece that we're putting into this equation so that it makes a nice square. So basically, we can factor all that equation down into x plus b over 2 quantity squared because it's a square, so one side squared. I hope that makes some sense. Now, I'm going to go back to the classroom and I'm going to go back onto Paint. I hope this visual aid was helpful. Welcome back to the Paint document. So, what are we going to do now? So, now we know why that this is the missing term that we're going to need to add and subtract from the equation to essentially complete the square. So, our b term is this negative 8. Remember, you got to keep that sign with this 8. So, let's solve this right over here. So we have negative 8 over 2 quantity squared. So negative 8 divided by 2 is negative 4. Sorry, I forgot to write the square here. And negative 4 squared is equal to 16. So now we know we need to add and subtract by 16 to essentially complete the square in this case. So now we're going to have x squared minus 8x plus 16 minus 16 equals negative 5. And we can get away with that. That does not change the function at all, because in the long run, these actually cancel. So we will group these together. Always group the positive one with the x terms. Now, this can collapse. Remember looking at that square. Essentially, it's going to be x plus b over 2. So what is b over 2 in this case? B over 2 is this negative 4 over here. So now we have x minus 4 quantity squared minus 16 equals negative 5. Now we can scoot that negative 5 over, right? So now we can get pretty much the same thing. X minus 4 squared, scoot it over, so it's essentially adding 5, so minus 11 equals 0. Now if this 0 was an f of x or a y, which essentially is the same thing. They're the same thing. Don't worry about what they are. I know that in math, a lot of times you start off with the y. Eventually, teachers start going into function notation and everything, and at that point there, people get a little confused. They are essentially the same thing, so don't worry about that. But this would be the vertex form if this 0 was a y. But because this 0 is here, it's actually signifying that we need to solve for the solution. So let's get that solution really quickly. So to get that as a solution, the first step you would do is to take this negative 11 and scoot it over to the other side. So simple enough, x minus 4 quantity squared equals 11. Now it's just about taking the square root of both sides. 11 doesn't have anything inside of it that can be square rooted. It's not going to be a nice square root. So now this 2 and the square root cancels. So you have x minus 4 equals the square root of 11. But because there's two solutions to a parabola, and because of the way that square roots work, this is actually a plus or minus. Just keep that in mind. That's just the way it works when you take square roots. Remember, you can have negative 2 squared and get 4, or you can have 2 times 2 squared, and that's also 4. So you got to keep in mind that you can have two different solutions from taking a square root. Now we just solve for x, which would be basically adding 4, right? So you have 4 plus or minus the square root of 11. So that is our answer. Thank you for watching. I hope you guys had a great time learning with me.